we're now going to look at the derivatives of carboxylic acids. And to start, I want to explain a little bit on the way that these have been categorized and why they are called derivatives. So as organic chemists look at carboxylic acids, and then we look at certain other functional groups, such as acid chlorides, acid anhydrides, esters, amides, and in fact there are other ones that we will not talk about in this class, but that you will probably encounter in things like biochemistry. What we see is that we could conceptually look at this structure as starting with a carboxylic acid and then replacing the OH with some other heteroatom group. So for example, if we replace the OH with a chlorine, well, now we get an acid chloride. If we replace the OH with a carboxylate, we get an acid anhydride, and so forth. And in fact, in several cases, it is actually possible to do this not only conceptually, but in fact. So for example, we are going to see that acid chlorides are made directly from carboxylic acids. So therefore, when we have substances that are directly made from a different substance, we can say that the new substance is derived from the original substance. So we could say the acid chloride is derived from the carboxylic acid, and therefore we would say the acid chloride is a derivative of the carboxylic acid. So once organic chemists recognized this, they sort of grouped all of these together, and we're going to see that it's a very convenient grouping for us because the derivatives interact, and many of the things we see mechanistically going in this direction apply to all of the derivatives. Now, nitriles are the very interesting sort of exception to this. They're technically not derivatives of carboxylic acids, since we probably, in my mind, I can't think of a, well, let me think. I can't think of a direct reaction to make a nitrile from a carboxylic acid. There's some that you can do it from amides, but not from carboxylic acids directly. But what we can see is that we can go in the reverse direction. So we can start with a nitrile and go back to a carboxylic acid we've seen earlier. So for lack of a better place to put it, nitriles are often included in the derivatives chapter just because there's a certain symmetry among it all. We're going to start our discussion of derivatives with nomenclature. Again, not the most interesting thing, but a very important skill to have. So we're going to go through each derivative in turn and show how to name it. What we're going to see is that most of the names are going to start with the name of the carboxylic acid from which the derivative would be made. So what we will do then is, in that case, we will say name that related carboxylic acid, and of course you would have to go back to the carboxylic acid naming rules and follow those rules to name it. Then what we will do is we'll take that carboxylic acid name, cross out part of it, and replace it with something else. So for example, for acid chlorides, what we do is we name the related carboxylic acid, and then we replace the ic acid portion of that name with the suffix il chloride. So for example, this acid chloride would be derived from acetic acid. So we would name it acetic acid, we would cross out the ic acid, and then we would place, instead of ic, we would place YL, and then we put a space, and then put the word chloride. So acetic acid becomes acetyl chloride or acetyl chloride. People argue over how to pronounce that all the time. Similarly, we have benzoic acid. So we cross out the ic acid, we put YL chloride. So this is pronounced benzoyl. So this is actually two syllables, chloride. And it's very important that we keep the O, because there is also a molecule named benzyl chloride with no O that has a different structure. Finally then, if we go back to butanoic acid, this is an IUPAC name. We would cross out the ic acid, so we'd keep the O. We would call this butanoyl chloride. Acid anhydrides are very interesting because of the way that organic chemists sort of conceptualize them. Okay? So the way organic chemists conceptualize acid anhydrides, we look at the overall acid anhydride structure, which looks like this. Has a carbon group, a C double bond O, an oxygen in the middle, another C double bond O, and then a carbon group, and the two carbon groups can be the same or they can be different. So organic chemists conceptualize this as being derived from two separate carboxylic acids, which would have carbon group, C double bond O, OH, then OH, C double bond O, carbon group, that have been joined together by one of the oxygens, and the other oxygen and the two hydrogens that would be present on a carboxylic acid have been taken away. And if we add up the formula of what's been taken away, that's a molecule of water. So they therefore named this as carboxylic acids without water, anhydride. Now, in order to name this then, what we must first do is identify the two carboxylic acids halves that would have been put together. We would name those, and we would remove the acid from those names. So, for example, acetic acid would just be acetic. Benzoic acid would just be benzoic. We would then list those names in alphabetical order, so acetic, then benzoic, space in between them, then another space, and we would add the word anhydride. Now, the only thing that complicates this is when the two halves would be the same carboxylic acid. In that case, what we do is, rather than saying acetic and a second acetic and then the word anhydride, lazy organic chemists strike again, we drop one of the names so that instead of having two acetics in the name, we just say acetic once, anhydride. So if you see only one acid name followed by the word anhydride, what that means is the two halves are identical and they're both that acid. With regard to esters, again, we have to look at how esters were conceptualized by organic chemists in order to understand how they are named. So what organic chemists envision for esters is that what they really are is carboxylates that have a carbon group attached to the oxygen of the carboxylate, so that it no longer has a charge, but it's basically a carboxylic acid. We've replaced the hydrogen with an alkyl group, a carbon group. So therefore, in order to name it, what they're going to do is they're going to name the acid part as the carboxylate. So you name the carboxylic acid, you drop the ic acid, you put the ATE ending. Then they're going to name the alkyl part as the alkyl group. We're going to put the name of the alkyl group first. We're going to put it in front of the carboxylate name, and we're going to put a space in between those two halves. So if we look, for example, look at this ester. So we can see that starting with the carboxylate portion of it, we can see that O, C double bond O, and then this carbon group, that's the carboxylic acid portion. So we're going to name that as a carboxylate. In this particular case, that would be acetic acid. So we would take off ic acid and we replace it with ATE. On the left-hand side then, starting on the bond after the oxygen of the carboxylate, we start right here. We have 1, 2 carbon in a chain, so that would be an ethyl group. So therefore, we would put the word ethyl in front, put a space, and then put acetate for the carboxylate. So this is a an ester that we used in a lab earlier this semester. In this case, what we have is, if we look, here is the O, the C double bond O, and then we have a phenyl group, so that would be benzoic acid. We take off the ic acid, we put ATE, so it becomes benzoate, and then our carbon group is methyl. So this is methyl with a space, benzoate. It takes a little getting used to, but once you get used to it, you'll see that it is actually a fairly straightforward naming system for esters. To name amides, what we do is, again, we start with the related carboxylic acid. So for example, we look at this, the carboxylic acid would be this structure where we'd have an OH instead of the NH2. So that would be acetic acid. So what we're going to do is we are going to drop the ic from the acid name, and then we're going to simply put on the ending amide. So for example, here's acetic acid with an amide, so it's acetamide. Similarly, here, what we're going to do is we're going to name this as butanoic acid. But what we're going to do is we're going to take off the O and the ic acid. So this is an exception to what we were doing earlier. In this case, we are going to remove the oic, the entire thing, and then put amide on the end. So butanoic acid becomes butanamide, not butanoamide. The only other complication we have with amides is that the nitrogen group itself can have carbons attached to it as branches. So in that case, we have the problem that when we have a carbon group attached to the carbon chain of the acid, that's going to be included in the carboxylic acid name, and it's going to be given a number on the carboxylic acid chain. But the nitrogen is not part of that number chain. So to solve this problem, what we do is carbon groups attached to the nitrogen are given the special location N. So in this particular case, for example, we have 1, 2, 3, 4, 5, so that's a pent. We have a methyl group on carbon 4, so it would be 4-methyl pentanoic acid would be our base. We would take off the oic acid and add amide, so it would be pentanamide. And then we have a methyl group on the nitrogen, so we would say N-methyl in front. Now the important thing here is that typically when we have more than one methyl group, we are in the habit of sort of consolidating the numbers and saying, you know, like 2,2-dimethyl or 2,2,3 trimethyl. But when we have an N-methyl, we don't usually consolidate that with a numbered methyl on the chain. So when we have an N-alkyl group, we don't consolidate it with an alkyl group on the chain. So what that means is that we would name this N-methyl separated from 4-methyl. So it would be N-methyl, 4-methyl, pentanamide. Finally, then, we're going to look at the nomenclature of nitriles. The nomenclature of nitriles is fairly straightforward. What we're going to do is count the number of carbons in the longest carbon chain that contains the nitrile. We include the nitrile carbon when we count it. So we start counting here, not there. So therefore, this one has 1, 2, 3, 4 carbons. It's a but. We would put in the unsaturation if there were one. So ane, ene, ine. Then we would append the suffix nitrile. Now, because the nitrile starts with a consonant, we will leave the E in the first part of the name. There is one common name that I want you to know for nitriles, and that is this one. This one is the nitrile that would be equivalent to acetic acid. In fact, if you treat this nitrile with aqueous hydronium and heat, you would get acetic acid as the product. So again, here's that acete, but in this case, to make the transition between the acete and the nitrile portion sort of flow better, they put in an O. So it's acetonitrile. This is actually a really commonly used solvent in biochemistry, so you should try to learn this common name.